In this work, we present a method to generate 3D human-scene interactions with semantic control. People constantly interact with their surroundings, and such interactions have semantics that can be described using combinations of actions and object instances. For example, sit on the chair. An effective solution for semantic-aware virtual human generation could advance existing technologies in AR and VR, computer games, and synthetic data generation. Previous works on human-scene interaction synthesis lack a mechanism to control the high-level semantics of generated interactions. Incorporating and controlling such interaction semantics is critical for creating virtual humans with realistic and interpretable behavior. To this end, we propose COINS for compositional human-scene interaction synthesis with semantic control. Given a 3D scene and interaction semantics, our task is to generate a human body performing specified interactions. We represent interaction semantics as a set of varying numbers of action-object pairs. We name interactions composed of one action-object pair as atomic interactions, and interactions composed of multiple action-object pairs as composite interactions. Our method of COINS first generates the body pelvis frame, which corresponds to where interactions occur. With the pelvis frame, COINS then generate the detailed body performing specified interactions. COINS can generate human-scene interactions with semantic control, retarget actions on novel combinations with objects, and compose atomic interactions to generate composite interactions. We represent each frame of interaction as one human body mesh and a set of varying numbers of action-object pairs. The human body is represented as a downsampled simple X body mesh with 655 vertices. We extend the body mesh with per-vertex binary contact features, and the positive contact features are visualized as blue. We represent interaction semantics with a set of varying numbers of action-object pairs to model the compositional nature of interaction semantics. Each action is represented using a one-hot code, and each object instance is represented using a point cloud. We then train conditional VAE models for both body and pelvis generation. The object tokens added with action embeddings are conditional inputs to both the encoder and decoder. Transformers are used to encode the object and human points in a unified latent space. The decoder outputs the human body with contact features from sampled latent code and a template body. At generation time, only the decoder is used. Motivated by the compositional nature of interaction semantics, we further explore the task of compositional interaction generation that aims to generate composite interactions using models trained only on atomic data. This can save the need to collect composite interaction data for training. We propose two simple but effective extensions to our method for compositional pelvis and body generation. For compositional pelvis generation, we first sample one latent code for each atomic interaction. Then, we optimize the latent codes to encourage the decoded pelvis frames to be close in scene space, and the latent codes have a high probability. Finally, we average the pelvis frames decoded from the optimized latent codes to get the composed pelvis frame. For compositional body generation, we extract action body part correlation statistics from training data. At generation, we feed multiple action-object pairs to the decoder network and mask the attention between each body part and object tokens paired with an action that has a low correlation to the body part. We evaluate the task of human-scene interaction synthesis on the Process dataset, which provides scenes with mesh reconstruction and instance segmentation and interactions with simple X body fitting and per-frame semantic labels. Next, we show the qualitative results and quantitative evaluation of our method COINS in experiments. For the task of interaction synthesis with semantic control, COINS generated more realistic interactions than baselines and achieves close realism to pseudo-ground truth body fitting in the perceptual study. COINS significantly outperforms the baselines in semantic metrics and scene sampling efficiency while achieving high physical plausibility. For the task of compositional interaction synthesis, COINS generates more realistic interactions compared to the baseline. COINS also achieves better scores in perceptual studies and other metrics than the baseline. Using COINS, we populate an architecture visualization scene of a modern loft with humans performing diverse interactions. A web demo, code, and data can be found with the shown link and QR code. Thanks for watching.